video, we'll be talking about OWASP Top 10, the 2021 version of it, part 1. So I decided to cut it out into 2 parts because if it was one part, just one video, it would be too long, so just bear with it. Anyway, so the first thing is, what is OWASP? OWASP stands for Open Worldwide Application Security Project. It's a non-profit foundation and it aims to improve the security of software, and it provides freely available resources, articles, methodologies, documentation, tools, and so on and so forth. So the resources that you can get from OWASP are, for example, the OWASP Top 10 that started in 2003, and it presents the top 10 most critical risks facing organizations. And it's been updated regularly, the last one being the 2021 version. Then there is the OWASP Developer Guide. It provides guidance and includes ASP.NET, PHP, and so on code samples in it. And it covers application level security issues. And the last one that was released, it was in 2005, but a draft is being worked on right now. Then there is the Testing Guide, which started in 2003. And the latest version was released in December 2020. And if you've watched some of my previous videos, I've talked about these testing guides before. It's a testing framework that aims to help understand the what, why, when, where, and how we test web applications. Then there is the ZAP project. So this is an open source web application security scanner. The latest version, as I am recording this video, was released in October 2022, and it consists of an intercepting proxy server, a web crawler, an automated scanner, passive scanner, a fuzzer, and adds-on that can be easily added to extend its functionalities, and many more things. It's the OWASP version of Burp Suite if you already used Burp Suite before. So we'll be looking at the top 10 vulnerabilities from the OWASP top 10 list on a descending order. So the first one is on the list is broken access control. First, what are access controls? Access controls are the things that determines who is allowed to access data, resources, and apps in general, and what they are allowed to do with it. We can take as an example website's administrative page that manages other users. This should be behind an access control. So only, for example, the administrator would be able to access to this page. So now that we've talked about access control, we'll talk about broken access control. So a failure in this could lead to multiple problems. Unauthorized information disclosure, like getting access to sensitive information from other users that we shouldn't have access to. Modification or destruction of all data. So if the access control is broken, someone could modify data without having the rights to do it. And accessing unauthorized functionalities. In other words, broken access control would allow attackers to bypass authorizations and allow them to view things that they shouldn't be allowed to view, or to do things that they shouldn't be allowed to do. So the common vulnerabilities from this is, in general, violation of the principle of least privilege, bypassing access control checks by modifying the URL, for example, if we do like path traversal, permitting viewing and or editing someone else's account by providing its unique identifier. That's talking about IDOR. We'll be looking at these just after. Accessing an API with missing access controls for post, put, and delete. Doing an elevation of privileges and many more. So before going into what are the mapped common weakness enumeration, what is a CWE? A CWE is a standard for classifying and describing the types of weaknesses that can lead to vulnerabilities. So here for broken access control, we'll get something like the CWE22, which talks about improper limitations of a path name to a restricted directory, path traversal. If you want to know what a path traversal is and look more into it, there is a video link down below that you can watch. Then there is CWE 200, which is exposure of sensitive information to an unauthorized actor, permission issues, insecure temporary file, and so on and so forth. There are many that are mapped to broken access control. Let's have a look at what are IDORs. So IDORs, or Insecure Direct Object Reference, is an access control vulnerability where we can access resources that we shouldn't be able to, thanks to identifier that refers to specific objects that are exposed. So for example, let's say we are logging into our bank account, and after correctly authenticating ourselves, we get to this URL. And you see that in the URL there is an ID equal a number. So on that page, we can see that the account number is the ID that is on the URL. So one thing we could do is change the ID while still authenticated to our own account. And if we end up with this, so if we can see someone else's bank information, even though we aren't here Nick Perry, that is an IDOR. Let's do the challenge. So on this challenge, they give us the login information, so which are root and 1, 2, 3, 4. Once we are logged in, we get this. So the thing that you can see here is node ID equal 1. So there is an ID here. What we could do is try to change the ID and see if we can see nodes from other users. Number 2, oh yeah, we can. So there's definitely an IDOR. And here marks new resolutions. And it says, do not IDs start from 1? Maybe go lower. So generally speaking, we know that in programming languages, a lot of programming languages would start with 0 instead of 1. So, and here we go. So if you want to watch a video that goes more in depth in IDORs, you can look at the video that I'll be linking down below. The next, or number 2 in the OWASP top 10 list, is the cryptographic failures. So cryptographic failures refers to any vulnerability due to misuse or lack of cryptographic algorithms for protecting sensitive information. So generally speaking, to provide confidentiality, we use cryptography. Before going into what's cryptography and so on, we have to know what are the data states that we have. We have 3 data states: the data at rest, data in transit, and data in use. If we take this example where you want to open an email, so you have an email server and you want to access to your email through the browser, you would be having a conversation with the email server that will send you the email to your browser, and so you can read it. So in this case, the emails that are in the server mail are what we call data at rest, while the email that is in transit is what we call data in transit. And then once it reaches your browser and you're using it, it's what we call data in use. So in these data states, what we want to do is for the data to be encrypted so that people can see what's in there, whether the data is in transit or the data is at rest. The only time where we want the data to be in clear text is when it is in use. And that is because we don't want anyone to be able to listen to our communication and be able to read our emails, or we also don't want the email provider to be able to look at what's inside our emails either. So cryptographic failures often leads to sensitive data exposure, for example, names, date of birth, financial information, and so on and so forth, and system compromise. So for these, we'll find the mapped CWE that are use of hard-coded password or weak encoding for password, clear text transmission of sensitive information, use of a key past its expiration date, inadequate encryption strength, reversible one-way hash, selection of less secure algorithm during negotiation, and so on and so forth. There are many other CWEs for this vulnerability. So now we'll be doing the challenge. So the challenge is this. We are presented with this web page. So the first things we should do is, so here there's an email, but when we are in front of a web page, the first thing we do should be to open the page source and try to read what's there. So in the page source, what we can see here is there is, okay, let's see if there's something else. Okay. So we can see that there's the login.php that we could open. Let's remove in the view source. But there's also assets. So here we can see that there is multiple things that are in assets. So let's open one of them. And have a look at the assets directory and see if there's something. And here we can directly see that there is this webapp.db. So what is a webapp.db? It's a database. So let's just download it. And then open it. So the good thing, there is two ways of doing this. We can either open it using the database browser for SQLite, or we can use the command lines. I'm just going to use this because it will be faster. So when we get here, what we see is there's two tables. There is the sessions and user. So we should, in the users table, there is the different column names, which are user ID, username, password, and admin. So let's browse the data. and go to the users table. So in the users table, there are 3 users with different information. There is the admin, Bob, and Alice. So if we look here at admin and we copy this, we can try and see if we can reverse this hash. So let's go to CrackStation. I'm just gonna get all of the hashes and see if which one are already there. So here we go. Sometimes I also ask myself if I'm not a robot. Apparently today I am. Is it a car? I think that it is a car. A motorcycle. Thankfully, I'm not a robot. And then crack the hashes. And here we end up with the passwords for the first two, which are, one is for admin and the second was for Bob. So let's just try and log in with admin. So here, username and the password. Yes, we did it. Yeah, I know. I should have answered to each one after the other, but it's fine. And that's it. The third vulnerability that is on the top 10 list is the injection one. So injection flaws are very common and they occur because there is interpretation of user-controlled input as commands or parameters. And injection attacks depend on the technologies that are used as well as how the input is interpreted. And we have multiple examples of that. For example, SQL injections. This occurs when user-controlled input is passed to SQL queries. As a result, an attacker can pass in an SQL queries to manipulate the outcome of these queries. There is the command injection, which occurs when a user input is passed to system commands. As a result, the attacker can execute arbitrary system commands on application servers, which would potentially allow them to access user systems. Then there's also cross-site scripting. Anyway, if you want to learn more about each of them, you can watch the videos about them. I'll link them down below. So there are many mapped CWE2 for the injection, like improper input validation, cross-site scripting, SQL injection, and many more. To prevent injection attacks, generally speaking, it's more about stripping the input and using allow list. Depending on the type of injection, there can be more, but let's just go with the general assumption of injection in general. So here we'll be having a closer look into what's command injections. So command injection occurs when server-side code makes a call to a function that interacts with the server's console directly. And An injection the web vulnerability will allow an attacker to take advantage of that call to execute operating system commands arbitrarily on the server. So the consequences for that are endless, because a successful command injection attack will offer many possibilities. You can list files, you can read files, run commands to do recon, use the server to do enumeration and looking for ways to pivot in the network, and so on and so forth. Let's take this code snippet as an example. So here we first verify if the parameter moving is set, that is passed through a get method. Then once this is verified, the variable moving gets what was passed down into the input field, and then the variable cow stays with the default, but just after that it verifies if the parameter cow was set, and if it was, the variables get updated. And finally, the program executes the function passthrough, which executes a command in the operating system's console and sends the output back to the user's browser. So if we see here, the command is formed by concatenating the two variables cow and mooing. And since we can manipulate those two variables, we could try injecting additional commands by using simple tricks. For example, what we have here is we end up with, in the variable cow, the default, and in the variable mooing, whatever we are entering in that input field. And once this is done, we get this. So if we wanted to exploit it, we first have to know how the application works behind the curtains. So there is a thing that we can take advantage of, and that is a feature called inline commands. Here in this command we have echo, and then my username is, and who am I. So what it ends up doing is the who am I command is executed first. We get the username, and after that the result is parsed, and it goes back to the outer command, which is the echo one. So it ends up being echo, my username is Adam, and then the echo is executed, which we end up with this result. So if we go back to our example, we would be putting inside the input the who am I with a dollar sign and in between brackets. And so once we do that, it's executed as this. So who am I is firstly executed, the response would be Apache, and then we get this answer. So let's try the practical that is given to us. It's asking us what strange text file is in the website's root directory. So let's do that first. Let's try and do whatever. So let's say hi. So that's what it does. Now let's do who am I? And we see that Apache comes out. Now, the first question was what strange text file is in the website's root directory. So we need to look at what is there. What we would be using is the command line ls. So we list. So to list, we would be doing this. And we end up with this list. 4 files, sorry. So one of them is this one. So the next question is how many non-root or non-service, non-daemon users there are. So one way of seeing that is looking at what's in the /etc/passwd file. So we'll be doing this way, cat and pass WD. And we can look here, and in this, what we'll be looking for is for the home directory for each one. So as you can see, there has been no login, no login. None of them is a non-service or like a normal user. So that's why we end up with 0. Then the next question is, what user is this app running as? So we already got the answer with the who am I, but I can still do it again. It's Apache. Then the next question is, what is the user's shell set as? So we can go back to the etc password. And here we'll be looking at the username Apache. And we can see here we have the shell is set to this. Then the next question is, what version of Alpine Linux is running? And we can find this information after a bit of searching. You can find this information in 2 different places, but I'm just going to give you one of them. It's this one in etc/os release, and you'll see here the version ID of Alpine or Alpine. And here we go. The next one in this list and the 4th one in this OWASP top 10 is the insecure design. So insecure design refers to vulnerabilities which are inherent to the application's architecture. So here the problem lies in the application's architecture or design and not really in the implementation. So secure design can have an insecure implementation, and then that means we'll get vulnerabilities. But an insecure design cannot be fixed by a perfect implementation, as we need security controls that haven't been thought of and never created to defend against specific attacks. So why is that? Generally speaking, it comes from a lack of business risk profiling in the planning phases. So this propagates to the final product or app, and not knowing the right level of security too is one of the problems. Another reason why we could have insecure design is shortcuts that have been introduced in the code to make testing easier. For example, let's say a developer disabled the one-time password validation in the development phase to be able to quickly test the rest of the application without manually inputting a code at each login. However, they forget to re-enable it and then sending it to production, which means this is a problem too. So we end up with this command weakness enumeration. Some of them, like generation of error message containing sensitive information, unprotected storage of credentials, trust boundary violation, insufficiently protected credentials, and so on and so forth. So we can take as an example of an insecure design is security questions for credential recovery workflow, which was prohibited by the NIST 863B because more than one person can know the answers. For example, you probably have seen before some type of game on Facebook or Twitter or any type of social media where they tell you, oh, your birthday is this, and so depending on when is your birthday, you can choose your stripper name, for example, or I don't know, um, or your serial killer name. And these can be used to find the answers to your security questions, like what is your your first pet's name, or what is your mother's maiden name, and so on and so forth. Another case we can study is the Instagram case. So a while ago, Instagram had this vulnerability. So when you forgot your password, to reset the password, there was a 6-digit code that was sent via SMS for validation. And an attacker could try to brute force the 6-digit code, which means you have from 0 to 999,999 or something like this, which is 1 million possibilities. So what was happening when one computer, one IP address was trying to attempt the different codes, it will get to 250 and then the next one would be blocked. So after 250 attempts, the user would be blocked from trying further. However, they found out that the rate limiting only applied to code attempts made from the same IP. So if an attacker had several different IP addresses from where to send requests, he could now try 250 codes per IP. And so for 6 digits code, you would need something like 4,000 IP at most. And that would be to cover like all possible codes, which you could think may sound crazy, but with cloud services, it's easy to get this number of IP and try in, and that wouldn't cost too much. And so as you can see here, the vulnerability is related to the idea that a user wouldn't be capable of using more than one IP address or like a few thousand IP addresses to make concurrent requests to try and brute force the numeric code. So the problem here is in the design rather than the implementation of the application in itself. And as this type of vulnerabilities, the insecure design vulnerabilities, are introduced at such an early stage in the development process, it often requires rebuilding the vulnerable part of the application from the ground up and is usually harder to do than any other simple code-related vulnerability. So the best approach for here is to do threat modeling first at the early stages of the development life cycle. Let's try it on a practical example. Here it says, get into Joseph's account. This application also has a design flow in its password reset mechanism. Can you figure out the weakness in the proposed design and how to abuse it? So try to reset Joseph's password. Keep in mind the method used by the site to validate if you are indeed Joseph. So here we are in front of username and password, but we don't know the password. Let's see if when I put I forgot my password, what it says. So enter your username. We want Joseph's username. And here there are questions. What's your mother's, sister's, son's, nephew's, neighbor's, friend name? This one would be difficult to get if we don't know who Joseph is. What's your favorite color? And what's your first pet's current address? Let's see with what's your favorite color. Generally, like, there are a lot of colors, but people tend to just use like simple one. Let's try black. No, that's not the right one. Let's try blue. Nope, still not the right one. How about yellow? Nope, not right. Green. And here we go. So we get the password for user Joseph has been reset to this. So we can do this, copy it, and go back to the login. And now login in. And remember to move private files out of the server. Okay, so probably in the private, and here we have the flag. And now the fifth in this list of OWASP top 10, and the last one that we'll be seeing in this video, is security misconfiguration. So security misconfiguration are distinct from the other top 10 vulnerabilities because they occur when security could have been appropriately configured but wasn't. So even if we have up-to-date software, the fact that we have poor configuration can make the installation vulnerable. So security misconfiguration will include poorly configured permissions on cloud services like S3 buckets, having unnecessary features enabled like services, pages, ports, accounts, or privileges, having default accounts and passwords unchanged, error messages that are too detailed and allow attackers to find out more about the system, server that doesn't use HTTP security headers or they aren't set to secure values like HTTP only. Also, the software can just be out of date or vulnerable and known vulnerable, and so on and so forth. There are multiple mapped CWE for this, like configuration or password in configuration file, improper restriction of XML external entity reference, sensitive cookie in HTTPS session without secure attribute, and so on and so forth. So for this part, we'll be looking at an example which is the debugging interface. So exposure of these type of debugging interfaces in production software is a common security misconfiguration. Debugging features are made available in programming frameworks to allow us to access to advanced functionalities and useful for debugging an application while being developed. And if the developers forgot to disable them, the attackers could abuse them. One example of such a vulnerability was something like Patreon when it got hacked in 2015. Patreon got notified on the 23rd September of 2015, and that was about an open debug interface for WorkZerg console. Then that was just 5 days before it was compromised, and they published a public security notice on the 1st October, 2 days after the compromise. So what is WorkZerg? So WorkZerg is a vital component in Python-based web applications as it provides an interface for web servers to execute the Python code. And it includes a debug console that can be accessed either via URL on /console or if an exception is raised by the application. So it will result in providing a Python console that runs any code we send, like this. And because we can exploit any code, in the end we can end up with an RCE, remote code execution. So here for the practice they say, try to exploit the security misconfiguration to read the application's source code. So here we go to the console, and once we are in the interactive console, it says use the WorkZerg console to run the following Python code to execute the ls-l command on the server. So import OS print s.popen and here we go. So the question that comes after, what is the database file name in the current directory? So this is the file name. Then next question, modify the code to read the contents of the app.py file which contains the application source code, and what is the value of the secret flag variable in the source code. So we need to change the print os.popen lsl with cat app.py. And here we go. So the question was the value of the secret flag. So let's go back up. Okay. I don't like doing it like this. And here we have it. Secret flag. So that was it for this part of OWASP Top 10. We've seen the first 5, the top 5 of the list today, which covered broken access control, cryptographic failures, injection, insecure design, and security misconfiguration. I hope you enjoyed this video, and until next time, bye!